All right. Good morning from my end this morning, right? So today is the second day we'll be handling the second day of our training for the first week of the second month, right? So we we were proposed to have let me see what we have. Okay. So for what's this? All right. So for this week, we're supposed to be handling advanced Python, pandas data frame, and advanced pandas. That's data frames and data cleaning. So we we dealt with data frame. That was last um on the first video. That's the first day, which is already on your channel. So today we'll be dealing on handling missing data. So it's still under data frames. Pandas, advanced pandas. So today is the day 2 of our training. So I'll be talking on handling missing data and data cleaning technique. So when you have a data, the first thing that comes into your mind before you begin to say you want to do your before you say you want to begin your model training and all of that, you have to first assess the data, right? And then when you assess the data, you'll be able to ascertain that that's the type of data you want. So how do we assess the data? By going through all. Okay, I just wanted to be sure I'm recording. Okay. Okay. So by going through all the variables for that particular data set, so you may want to call it columns in that particular data set. So it's still fine. Then um, secondly, we are also going to, after you assess the data, now you know that this is the data you want, right? What next do? You go ahead to the uh spot the nature of the data. What is the integrity, rather, the integrity of the data? Is it clean? Do you have to do some touches to it? And all of that, right? So the main game or the main task you're saddled with is the data cleaning itself. So data cleaning is a technique that is used to ensure that your data is void of null values and as well is within the jurisdiction, or most times they call it distribution. It's between the distribution quota that will be suitable for that your prediction or that your model you're trying to develop. By so doing, it will help um, spoil you up, or it will help not spoil you up, rather, it will help improve your model's performance. All right, so that's why I actually said we should do the handling of missing data and data cleaning technique. So when there is a data missing, or when there are data points missing in our entire data set, we realize that it affects our statistical parameters. How do I mean our statistical parameters? When we have the statistical summary of this data, and we are having um, missing values, you realize that that particular data set tends to have a higher, or rather a lower mean, right? So it will affect the mean, and which it is very, very important. So your ability to spot out those missing values and treat them or handle them properly will go a long way to um, help control your data distribution. So what are we going to do today? The first is handling of missing data. So a missing data is a common issue in data sets. It is usually a common issue, right? So most times you issue out either a Google form or a survey, like a questionnaire, to a group of people or a sample of a population, right? And then you realize that these guys that were supposed to or normally fill in every single or respond to every single question in that your survey tends to ignore some of the questions, right? So no wonder why most people, when they want to issue out a Google form, that's a survey form, or a questionnaire, they will be like, all the questions are mandatory, right? So for those that are soft copies, it will be stated that all the questions requires an answer. And if you don't answer them, you can't proceed to the next question, right? So in such cases, it's that act that is being done there is just to ensure we don't have a missing data at our database, right? So, but then there are still some stubborn guys that will not want to feel everything, right? And when you encounter such scenarios, such cases, you try to do what you see how to handle them. But it doesn't just fall down to survey forms and questionnaires. There are times where we have work schedule, and then we have the responsibility of seeing that we acquire data from the work we do, right? So how do we then acquire this data? So we set up smart systems to help acquire this data on real time. And then when you're done with the job, you can now go ahead for the interpretation and seeing how you can make use of the data correctly. So there are times where we have technical errors from those machine or devices that you use to read off your data, right? So it's like the regular one we know when you're doing your well logging, right? And then you're using either an electrical well logging device. So once there is discrepancy, like it doesn't capture for a particular zone in your well, you realize that when you upon analyzing or interpreting that particular log you have acquired, you may tend to have issues because those spots or those zones you couldn't capture will form part of your missing data. It also impairs on some other light tags, like trying to read off your pressure from your gauges, trying to read off your flow rate and all of that, either in the process facility and all of that. So you realize that if your device is not capturing every single value, you may tend to have missing data in your data set at the end of the day. So our task is to see that when we have those kind of scenarios, we must handle them appropriately to ensure that the data, to ensure the integrity of our analysis, right? So we don't want to be biased, such that, okay, let's say for instance, uh, we're in a job and then you want to acquire some basic data, like your PVT data from your pump, right? So you have a data acquisition system rigged up to your pump, and you can now see on real time the acquisition that is being done. So if there be any mistake or if there be any issue that either your magnetic pickup does not make contact with the wheel, so you realize that at some point it might not be able to account for a complete rate. So when we are now doing the analysis, the in-house analysis of that data we've acquired, we'll realize that we'll need to see how to account for those particular times where either our magnetic pickup could not uh, capture those data, right? So your first thing in this particular um, topic today is you first need to first know how to identify missing data. Sorry, I'm just using the oil and gas industry as um, for illustration, for which I know or most of us should be aware of, right? So identifying the missing value. How do we identify this missing data? So Pandas has provided us with methods to detect missing data. And for now, I can give us um, two very good methods. The first is, sorry. So the first is null method. So is null method returns a data frame of Boolean values indicating where values are missing, right? And not value. So for not value, it returns a data frame of Boolean values indicating where the values are present. So there are two things now. We have is null. So whenever you say is null, it will do what? Try to return a data frame that indicates the spots where you have missing data. So while not null will return a data frame that will do what? Ignore, or that will show or display your data points that does not have missing values. So it will not incorporate those missing data points in your data frame. So when I say data frame, I'm just talking about the table or your data sets, the rows and the columns. So that's just what makes up the data frame. So first, you import pandas as PD, and then we borrowed this guy because I needed to create a simple data. So I borrowed this guy, import NumPy as NP. We're still going to talk about this hopefully next week about NumPy. So we have a sample data frame with missing data here. So I have a data, mind you, for me to create my data, I need to have a dictionary, right? With my key name. So I have range of names here, and then age. I have ages here, and city, right? So I have different cities here. So for me to create a data frame, df equals to pd, the pandas which have imported, dot data frame. We should have learned this thing from the previous video. So dot data frame, open or close brackets, data inside of the bracket. So this data we are creating here is the data frame. So let's print the data frame. We are trying to identify the missing values now. When we print the how do you call it? The data frame, it should display to us, right? Then print missing values is null. So it will just be df dot is null. So once you type df dot is null, it will automatically print out the spots where you have missing values. Then the non-missing values are df not null, right? So if I should run this guy, you see what I'm talking about. And this is our first data frame we created. So this is the first column where you have name. So mind you, we have Alice, Bob, David. So we have a missing value here, which is NaN, right? So this NaN is usually not a number, not a number. So there, that NaN indicates that there is a missing value there, right? And the same thing applies for the age and what the city. So let's look at missing values is null. Missing value is null. So is null, when you say is null, what it will do is that anywhere there's a missing value, it will indicate true, that there is a missing value. So invariably, what we are trying to do is you're using you're giving your PC that command. Yeah, ask and be like, this is a question. Is there a missing value here? So when it says false, that means there's no missing value. So to all the data points that is bearing false, there is no missing value, right? But the places where we have true and true, it means what? There are missing values. So we have realized that there are missing data points in three different areas here and there. And then non-missing values. We have non-missing values, like when you say not, so you're asking, hope there is no missing value. Here you say true, there's no missing value, true, there's no, but at this point it's a false. I'm thinking there should be a missing value here, right? So it pops up false for you, false and false. So that already indicates that there is a missing value there. So how do we handle this missing values? Very, very important. How do we handle missing values? So number one, that how do we handle missing values? Number one, you can replace or you can fill in those missing values with uh, with another with specific values. So the first thing is you can, with respect to experience and domain knowledge, you can make use of the field NA and then indicate a particular value that you can use to fill in that spot. All right, so let's go this way. Uh, let's say, for instance, we have a column of age, and or or with respect to the projects you're working on, you are aware that there's a missing value in the age column, right? AGE, right? And then you're trying to see how to rectify that issue, right? So because it that why I use age is because age is usually rampant. Most guys don't want to disclose their age. All right, so what you will do now, you will fall back to the aims and the objectives of that particular project. You try to see the range of ages of persons that were supposed to participate in this particular survey, right? So it could be that we have people from the ages of 19 to 30 that were supposed to participate, right? And you're having somebody enter 60 years, 100 years, and all of that. So those guys are uh okay, those ones are actually extreme values. So you're having somebody not entering any value at all. That's where we are talking about missing value. Those extreme values, we'll still talk about them. So for this particular scenario, what you do is either you use any of the statistical value or any of the statistical parameters of that particular column. So when I mean statistical parameters, it could be the mean, the median, or the mode of that particular value, of that particular column. So if you're using the mean, remember the mean is usually one value. So that's why I say fill NA with a specific value. So it means that all those areas in that your column, we have what we experience, or we have just that same value. And then you can as well interpolation method. So interpolation method, how do we do that? Is a kind of a backward and a forward kind of interpolation we do, right? So you fill in some part with the first value, or rather, let me say the forward value. How do I mean the forward value? So I have here true, rather, let's go to the actual data. I have here David, right? And there's a missing value here, and I have here Bob. So what do I do? I can decide that interpolating between these two guys and decide that with respect to the algorithm I'm going to use for my interpolation, most times we make use of the k nearest neighbor. So the data point which is closest to that particular spot where there is a missing data should be used to fill into that particular spot. So that is one of the second methods we can use for filling missing data. And then you can as well remove those missing data, right? It's just like you're in a meeting, and that meeting is it was expected that everybody should contribute, right? And you have this person so very much aloof and he's not even contributing anything. So you can decide to you can leave us. That means you do not make sense to us, right? So how do we now know when a missing data does not make sense to us? Number one, it's the ratio of the missing data to the existing data or to the non-missing data should be very, very low. Very, very low. It should be less than 0.5%, right? So that's you realize that when you drop the when you eliminate the missing data points, it shouldn't affect the integrity of the data. when analyzing, because most times when you reduce the data points, you would not be able to do what get the wholesome analysis as the case should be. So how do we drop? You just use the syntax, drop NA, open bracket, axis, the axis where the NA is. So it could be for a row. So when it's for a row, use your axis to be equal to what, 0. But for columns, use your axis to be equal to what, 1. So 0 represents your rows and 1 represents what, your columns. So let's see how we can fill in missing values. So we have here filling missing values. We have df underscore fill. Remember our original data set was known as df, which is the short of the abbreviation for data frame. So we now have df dot fill na. Remember, we said if you're filling, you make use of what, fill na. And then for name, what do you want to fill in name? Fill unknown. So once you give that name a particular name, which is known as unknown, it still boils down to it will still help us when we are doing interpretation or when we are doing our analysis, such that we can say that there are persons that we don't know their names, right? And then for the age, you can fill the age with the mean. Remember what I told you about statistical parameter. So you can fill it with the mean of that particular column. So that's what we did here. And then the city unknown, because we can't just predict somebody's city except we make use of the interpolation, right? So print data frame with field values, right? So let's take this guy off down to the next column and see what will happen. So let's bring him here. All right, so let's try to run this. So you realize that we are having unknown, and then we are having 30.0 here. So if you look at it very closely, it's within the range because we are making use of what? A statistical parameter. And then we are having here unknown. The city of Bob is not known as well. So also we said that we can decide to do or drop the missing value. So df underscore drop equals to df dot drop na. So you drop na, open and close the bracket. So when you open and close your bracket, it will drop all the, why I gave this axis here is most times you might know the particular column or the row that is giving you that headache. But in cases where you don't know, how do you handle that? So you just make use of what your drop NA, open and close your brackets, right? And that's you account for that. So print data frame with missing rows removed. So this is it. So we run this guy. We're having just 2 rows of data. So if you look at our data from the beginning, we have just this guy. We have Alice with full data, and then okay, I'm coming. So we have just Alice, right? Sorry, I made a mistake there. So just Alice remaining because all other guys have 1 or 2 missing values. So this guy, there's no name. Bob has a missing value, which is for city. David was not so open to disclose his age. So let's try to um explore some other form of data cleaning technique. Mind you, handling of missing value is very, very much what's vital and important. So cleaning data ensures consistency and accuracy in the data set. So what do we do? The first data cleaning technique is what? Renaming your columns. So your columns can be renamed using what? Rename, open and close bracket, right? Columns equal to what? Old name then colon, what? New name. So it's just as if you're using a dictionary format here. So you specify the old name and then the new name you want. The same thing is applicable for columns. You can do this columns equal to new column. So when you want to rename all the columns, so you now come and enter the new columns. So uh we have types of columns, or will I say types of data, right? So in your column, when I mean column, yeah, you should know we have the vertical and the horizontal. So the vertical guy should be is always your column. So how do we convert the data types to ensure proper data representation? So when we have uh, the numbers, we are expected to see what either integers or floats, right? And not to see things like objects. So when there is an object, when you have a value and you're seeing objects there, it means that that data has some issues, right? So how do we convert that as type, open and close the new data type that you want so to convert to specific um, data type. So let's still bring this code down, and so uh, we don't do what complicates the code for you. So we want to rename the columns first. So for name, uh, we have full name, right? We have full name, age, we have years, right? And then print data frame with rename columns, right? So this will be it, the renamed column. So if you run this code, you should be having what? Your full name and the years and what your city compared to the previous time where we have name, age, and city, right? Okay, so another thing, where are we? All right, here's the full name. So we talked about converting data types. So if you look very closely, we have years, or we have age from our normal data, right? So we can decide that the age should be a floating uh, number, right? So you have df, open and close brackets. So this df is your data frame name, and the age is a column, right? Then that means you want to have this column will exist already. So whatever you're doing here, it means you're editing the column. So this other guy will account for uh what as type floats, right? Df, open and close bracket, age dot as type floats, right? So we print data frame with type conversion, right? So if you run this guy, hope I'm still on the call. Hope so. Okay, so as I was saying, we'll now have what? Data frame with type conversion. We have name, we have objects, so age, float 64, city, objects, and data type objects, right? So our age is now what? A floating number. So removing duplicate is another form of data cleaning um, technique. So why do we do removing of data of duplicate? Duplicates will make our model to do what? It will cause our data to be collating. So there's something known as multicollinearity, where two two variables in your data are speaking the same thing. So if you're having two persons speaking the same thing, no, it wouldn't really help, right? So how do we do that? Drop duplicates can be identified and removed using duplicated, right? Then it returns what? A Boolean series indicating duplicates. Then drop duplicates, removes duplicates rows. So here is it. I created another data frame that has duplicates like Alice, right? New York, 25, 25. So uh, we have this duplicate so we identify the duplicates first. So let's remove this guy. When it's time to remove the duplicates, I'll let you know. So we come here. When we run the sample data, duplicates rows. So you have false, we have false, and we have what's true. So where there's true, it means there's a duplicate value there. So how do we drop it, or how do we remove it? Number one, we make use of what? Drop df underscore duplicates dot drop duplicates. So this dot drop duplicate is what we remove the duplicate. It's usually advisable you drop your duplicates regardless of how the size of your data. So I have an hands-on practice here. You create a data frame with this data, right? Product, price, and quantity. Then identify missing data, missing values, rename the price to cost, and then remove duplicates if there's any duplicates. So I have a brief syntax that you can play around with. So that ends the class for today. Thank you very much.